right, everyone. This is the 2A.1, it should say to 2A.3, abbreviated notes. What that means is that I have taken the notes that were on, that are going to be posted on Ivy Learn, and I've removed all of the questions from those notes for this packet right here that are Kahoot questions. Now, your file in Ivy Learn will still have all the questions. This is just to help me know not to cover the ones that you're going to do on the Kahoot. So watch this video. It should not be as long as a regular class session, so that'll be good. And then remember, your only in-class participation for the Monday we're going to miss due to the holiday is to do the Kahoot that I post right underneath the video. This is going to be posted in announcements, and it'll also be posted in the module too. So, and you do not have to do it on Monday. In fact, we are not supposed to have assignments due on Monday, but it just needs to be done before we meet again on Wednesday of next week. Okay, so let's talk about 2A1. This section covers something called per capita and scaling. Per capita means per person. So like if you hear on the news, they say something like, we have school funds per capita, that's school funds per student, per person. So Antonio and Juliet are opening a new business. They decide to send informational packets to relevant businesses and extended community. They are including 3 things in each packet and creating 400 packets total. So this 3 things in each packet seems to be extra information to me because the total number of packets, regardless of what's in the packets, is 400. If there are 5 people creating the packets for distribution, what is the number of packets per capita? So how many packets are being made per person? Round to 2 decimal places if necessary. Now the per is where the division bar is. So notice this is total number of packets over a total number of people that they have working on this. So that's 400 divided by 5, which would be 80 packets per person or per capita, if you want to say it that way. Okay, let's look at our next one. A 3rd grade classroom consists of 24 students and we have 1 teacher. 1 student brings in individually packaged candies to share with the class and the teacher. So, okay, all 25 people, it looks like, are going to be getting something to celebrate their birthday. There are 150 pieces of candy for everyone to share. If everyone receives the same number of candies, find the number of pieces of candy per capita. So we're looking for pieces of candy per, so that's our division bar, capita. So we had 150 pieces of candy. We had 25 total people who were going to share it because all the 24 students plus the teacher, they are going to share with the teacher. And then we want to reduce that. Now, when we're reducing, remember, you're trying to get to, and they say, actually, we can go ahead and divide on this one. Because if they give you rounding directions, you can go ahead and divide. If they say reduce to the lowest fraction, you need to find something that divides equally into both top and bottom. And this ends up working out evenly, so we don't even have to worry about the rounding to 2 decimals. So it'd be 6 candies per person or per capita. And you could write that either way. They're both mean the same thing. And notice, remember on Newton, you would probably just be entering in the numerical part, the 6. All right. Notice this one. I did this on purpose because sometimes they'll throw in randomly when you're doing those homeworks because it kind of just gives you automated questions. They might switch the wording and have per hotel or per something else instead of per capita. And that is purely to make sure you are making sense and reading the actual question. So it says the city of tourists have 298 hotels with a population of 386,202. In tourists, how many people do they have per hotel? So notice this is not per capita. This is people on top divided by the number of hotels. And then it tells us to round to the nearest whole number. So 386,202 divided by 298. That would be 1295. And then the 9 at the decimal point, we'll round that up to a 6. So roughly 1,296 people per hotel. Okay. All right, we want to also talk about using proportions to do what's called scaling. Scaling means that you're trying to figure out the number. So like if you it's like kind of almost like population density type problems. You have, say in a state, that there's a total number of people and there's a total number of businesses. Well, you may want to know how many of those businesses are there per every 10,000 people or for every 100,000 people or for every million people. And the reason sometimes we want to know those kind of things is to look at the distribution of, like services. Obviously, it's not going to be spread out equally because places like Indianapolis or Chicago, they're going to have a lot more of those businesses probably readily available in their area compared to other cities. But if you think about it, that kind of makes sense because they're going to be more heavily populated. So scaling is really not too bad. It's just the proportions like what we were doing before. So notice this says in 2021, there were 6,497 licensed Starbucks locations in the US. The population in the US at that same time was 332.9 million. What was the rate of Starbucks locations per 100,000 people? So notice we are not trying to figure it out for the whole United States. We're just saying for every they're kind of rough estimating. If a city was 100,000 people, how many Starbucks would we maybe expect to see in that city? Okay. All right. And again, would not be completely accurate because, like I said, Chicago might have a lot more Starbucks than a place like Greenwood, Indiana. Or maybe not, depends on the population that actually lives there. Okay, so the total number of US Starbucks locations, so I have that on top, over the total US population. Notice I put that in scientific notation and that I had to because this population number was not in millions. So we can't just ignore the word millions because these are different formats. We need that times 10 to the 6. And I don't use the X for these mainly just because that gets confusing with your variable. So I just times with a parentheses. Okay, so 332, and I'm not even going to change that to proper scientific notation because we're going to be doing all this multiplication and stuff. So we're going to have that will be how many Starbucks are there? So that's what we're looking for over the scaled down population of just 100,000 people. So when we cross multiply, we'd get 6,497 times 100,000. So that's on top. And then remember, you always divide by the one that's across from X. So notice I've got that written there. And then let's just double check my math. So when I type something like this in, I put the entire numerator in its own parentheses, and I just use the time symbol. So that's the top. And then I do my division bar or my division symbol. And then I put the whole denominator in its own parentheses too. So 332.9 times 10. And then we have our to the power of 6. Close that parentheses. And notice that's just the answer for the bottom. It's not giving me the final answer until I hit my equal sign. So notice that is the 1.95. If we round to 2 decimal places, Starbucks locations per 100,000 people in the US. So roughly about 2. If they had us round to the nearest whole number, we'd say there's probably about 2 Starbucks locations in a city of 100,000 people. And again, like I said, estimated, not exact, because obviously Wyoming and Montana and like New York, all those different states are going to be very differently dispersed with their populations. But this is a proportionality relationship. Okay. All right, so that ends 2A.1. So remember, we're going to be going through these kind of quicker because all of the little you try questions are going to follow in the Kahoot that you're going to try on your own. Now 2A.2 is the percent proportion, translate and solve. So we're going to be looking at how to do proportions using percentages. And then our second part of that, 2A.3, will be how to do percent problems using an equation method. So we're going to learn 2 methods for solving these, and you absolutely can choose on the midterm which method you want to use. We just give you a problem. It doesn't necessarily say use method from 2A.2 or use method from 2A.3. You just have to use the one that makes the most sense to you. Now, I highly recommend, though, when you're doing the homework, you practice using the method from the specific section that you're in, just so you can see which one you actually like better. So 2A.2 is percent proportion. So using the proportion method for solving percent questions can make the task much easier. And this is actually my preferred method. I always share this with students. Everybody has a favorite. 2A.2 is mine. Additionally, the percent does not need to be converted to decimal form to complete the calculations. That's why I like this one. You put your percent in exactly in a percent because you're going to put it over 100. That's why you can leave the percent as it is. And then you're just solving by cross multiplying. So you're going to be having questions like this where they say blank is what percent of blank, or what is a certain percent of blank. So you're going to be finding one of these 3 missing pieces and you'll have the other 2. So when we set these up, we have our part we're considering over part we're comparing to is the percent over 100. Now, that is not always easy to determine what are you considering or what are you comparing. So we use keywords. The is over the of is equal to the percent over 100. Another way of thinking of that is your part over your whole is equal to your percent over your 100. You could also think of it as the amount you're given over the base is equal to percent over 100. And then later on, we will use this in a further section. The new over the old is equal to the percent over the 100. We use this one when we do markups and discounts. So what's the sales price versus what's the original price, okay? But I like to stick with this first one right here a lot of the times because when we're just doing these basic translations, this really helps you see what we're doing, okay? So we're going to set up our template and identify what labels we know. 100 is always a free spot. It'll never change. It's always percent is out of 100. Identifying the part of the is and the whole, which is the of, is key. So let's read this first one. It says 60 is 57% of what number? And I am going to put general rounding rules for all these. We're going to round to the nearest tenth. That wasn't typed in the notes, but we are going to follow that. If we have any rounding to do, it'll be to the nearest tenth. Okay, so 60 is 57% of what number? So we have our 60 is, we have our 57 is our percent. We are missing the of. So if we write is, which would be 60, over of, which I don't know, the percent we would write in as 57 over 100. This is just cross multiplying. So we're going to write 60 times 100. That would be 6,000 equals 57 times x. So that'd be 57x. And then remember, you always divide by the one that's next to your x to isolate that x. So we divide this by 57. I believe we will need to round this one. Yeah, this would be 105.3 because we have a 2 in the 10th place, but there's a 6 behind it. So x is approximately 105.3. So if you reread that sentence now, you can say 60, the number 60, is about 57% of 105.3. Okay, so a little over halfway to this number. 43 is, we're looking for the percent this time, and we have the of, the 90. So 43 is our is, 90 is our of. We don't know our percent, but we have our free spot of 100, remember. So 43 times 100 is 4,300. Then we have 90 times x, which would just be 90x. We're going to divide 4,300 by 90. And we're going to be rounding this. This is already, and this is why I love this method. When you use proportion method for percent problems, so this is called percent proportions, you do not need to adjust this at all. This is the actual percentage. We will round it to our nearest tenth, but this would be 47.8%. Now, this next method we're going to teach you in the third section, you convert percentages to decimals when you solve the problems. So at the end, you have decimals you have to convert back to percents if you're solving for the percentage. That's the extra step that sometimes people will forget. So that's why I love percent proportions, because you don't have to think about that. It already is the percentage you're looking for. Okay. And then our last one for this part is what is, so we're missing the is, and we have 15% of 92. So is missing. 15 is the percentage that goes over 100. And we know the of is 92. So this time I'm going to have to do 15 times 92 because those are the two numbers we have that are across from each other. So 1,380 equals 100x, divide by 100. Divide by 100. Should just move our decimal 2 places to the left, and we get 13.8. So if you read this now, the number 13.8, and that's exact, it came out exactly, is 15% of the number 92. Okay. All right, so that's percent proportions. That's the basics. Let's look at a couple applications. And remember, these numbers will change when you print out, if you do the printouts of the notes, because I've removed, like I said, all the ones that you would have filled in for the Kahoot part. So don't worry if you have some that you have to skip, because that's what you're going to be filling in when you do the Kahoot. So set up the percent proportion and then solve. Round to the nearest whole number if needed. So in a tree planting project, 300 of the 410 trees planted were still living 1 year later. What percent of the trees were still living? So we're looking for the percent. Notice that this says 300 of the 410 trees. They didn't have an is here, but they definitely had the of. This is the part and this is the whole. So that's the of. So we have our is, we have our of. We're looking for the percent and it's over 100. So we'll do 300, oops, times 100. That's 30,000 equals 410 times X. We'll divide by the 410. So that's going to be to the nearest whole percentage. They said to round to, this is going to be 73%. And notice this is a percentage, so I am putting a percent symbol on it. You don't do that unless you're solving for the percent. So roughly 73% of the trees survived. Okay, let's look at our last one in 2A.2, I believe. Yep. So after 4 months, Jasmine lost 9% of her original weight. She lost 15.3 pounds. What was her original weight? Okay, so this is the part that she lost. We're looking for her original weight, which would be her whole. Okay. So, and she lost 9%. So notice that lost part needs to match. When you match these up, the percentage on top should be directly related to the number that we're matching on the top on the other side. So that is, this weight loss is 9% of her whole weight. So we're looking for her whole weight. So we're going to do 15.3 times 100. So that's 1,530 equals 9x. We'll be dividing by 9 on our calculator. So it's 170. So her original weight before she lost anything was 170 pounds. So you could figure out her new weight, what does she weigh now if you really wanted to by doing 170 minus 15.3, but they didn't ask us for that. They just said, what did she weigh before she lost the weight? So 170 pounds. And that leads us to our last section. So hopefully this won't be too long for you guys and you'll be able to get through and get the Kahoot done. So 2A.3 is about percent equations. This is just a different method of doing exactly the same problems we just did in 2A.2. So I'm not going to spend as much time doing a bunch of these as really it's just an alternate method. We'll do a couple, but we want to make sure first we have our ability to convert between decimal and percentage down because that is required when you use the equation method. And the reason this is required is because the 100 is not a part of what we see. In the proportions, you had the 100 as part of when you were solving because you were using percent out of 100. What you're doing in these is you're actually dividing your percent by 100 and turning it into a decimal. So you're not seeing that 100 show up, but it's in that conversion to decimal step. So essentially, these are just already written as an equation, and you're just writing your 3 pieces in, and then you solve. The only hard part is you have to be careful if you're solving for percent because you're going to get an answer that's in decimal form, and you have to remember that the percentage needs to be times back by 100 and turned into a percent. So that's the big part is that one has that extra step in it. So I just really look at this first one here, kind of the amount is the percent as a decimal times the base. Or you can think of it as the is equals the percent as a decimal times the of. Another way of thinking of that. So when using the percent equation, remember you must put percents in decimal form when you're plugging them into the equation. And if you're solving for the percentage, you must change your answer from decimal form to a percentage at the end. So let's just practice this. So remember, changing from percent to decimal, you move your decimal 2 places to the left. So this would be 0.203. This one would be, we'd have to add a 0, so that's going to be 0.0378. This one, the decimal's at the end, so if you move it 2 places, because that's all we do, we're dividing by 100 essentially, you'll just get 3. And this one's going to get even smaller, so that'd be 0.0022. Now, if you were solving for your percentage, and let's say these are the answers you get at the end, you have to remember to move it back 2 places to the right and then add the percent symbol. So 97%, 367%. This one would be 0.347%. So it may not even be a whole percentage, just depends. on what you get for your decimal. Could be more than 100%. That is possible. And then this one would be just 8%. Okay. So, and again, that step right there, converting a decimal back to a percentage, you don't do that if you're solving for the is or the of. You only do it if you're solving for the percentage. So let's look at this one. So it says translate it into kind of a sentence and then convert it into an equation essentially. So what number is 45% of 90? So I put X because we don't know what number is 45% as a decimal of the whole, the 90. Okay. So is in math means equal sign. Of means times. So we get X equals 0.45 times 90. And you can check that. That's 40.5. Okay. So 40.5 is 45% of 90. So not quite half. Okay. All right. So here's another one just so you can see. One serving of a crispy cereal has 8 grams of fiber, which is 25% of the recommended daily amount. What is the total recommended daily amount of fiber? Okay, so notice we know just the one serving they ate. So this is not their whole day of meals. This is just the part. The total recommended daily amount would be the whole. That'd be all the fiber that you ate for the day. So that's our of. Okay. So 8, that one serving that we ate, is 25% as a decimal of how much fiber are we allowed to have, okay, for the whole day. So 8 equals 0.25 times X, because we don't know what the X is, so it's just our variable. Now, in this case, you're going to divide by 0.25 because you're trying to get the X by itself. So 8 divided by 0.25. We always divide by the number that's next to our variable when we're solving these last steps. That's going to be 32 grams. So you're allowed to have 32 grams of fiber a day according to this problem. Okay. All right, we have just a couple to try together. Translate and solve. 4,250.2 is what percent of 26.9? Now, just off to the top of your head, you should already know this is way more than 100% because the is the part, and this is supposed to be the whole, and this is way bigger than our whole. So I'm already expecting a percentage more than 100%, quite a bit more actually. But let's go ahead and solve it. So we have our 4,250.2 equals what percent? So I don't know my percentage, and then times 26.9. Remember, we said you always divide by the one next to this. And this is where you could get yourself into trouble with these problems. Because when you divide this, it's already going to look huge. Because just the part is so much bigger than the whole. But this is not your percentage. This is in decimal form right now. So to make it a percentage, you have to move that decimal 2 places to the right. So the decimal's at the end. So it's 15800. This is actually saying that, yeah, 4,250.2 is 15,800%. It's that much larger than 26.9. It's very, very, very overinflated there. Okay. So I just wanted to point one out because sometimes students would just see the 158 and they'd be like, oh, that's my percentage. Not when you use the equation format. If you wanted to do the same problem, just to prove that to yourself that it really is that big, do the is over the of, like we did in the previous proportions, equals the percent over 100, like we did before, because you can solve these problems both ways, equation or proportion. We got 4,250.2 times 100, and we divide that by 26.9. And notice I like the proportion method better because then I don't do anything else. I just say, oh, that's my percentage. Whereas here I had to remember to move that decimal. So I don't care which method you use. Whichever one makes the most sense in your head is one you should use and the one that you're the most accurate with. But this one has a lot less room for wiggle error with the percentage part. Okay. Okay, so we have just a couple more. Mitzi received some gourmet brownies as a gift. The wrapper said each brownie was 480 calories and had 240 calories of fat. What percent of the total calories in each brownie comes from fat? Okay, so the fat is the percentage we're looking for. So we're looking for percentage of fat out of the whole amount of calories. So that would be the 240 is the fat calories. The total calories from that brownie were 480. And this one's going to be 50%. It's easy to see that because that fraction reduces to a half, but let's solve it. So 240 times, times not divide, by 100, and then divide that by the 480 since that's across from the X. So this is going to be, and this is again, if I use proportion method, I just get 50%. If I solve this one using the equation method, we would have had 240 is what percent? So I just want to show you both methods work. So on these last two, I'll probably solve them both ways. Of the 480, so this would have been 240 is what percent of 480? You would have divided by 480. And notice when you do that on your calculator, you actually get 0.5. But because this is the equation method, this is the proportion method, when you do the equation method, you have to physically remember to convert that to a percent. Okay, so that's the difference between the two. All right, and then our last one, Ben gets paid $4,850 per month. He pays $1,553 a month for rent. What percent of his month goes to his rent? Okay, so on this one, you can use either one, but I'll show you both. If I use the proportion method, we'll just abbreviate versus if I use the equation method. So proportion, the rent is the part. So that's going to be 1,553. His whole amount that he gets paid is 4,850. And they were asking what percent goes to rent. So what percent is rent out of all of his money? Okay. So if we solve this one, I might not show all my steps. Let's just see if we can solve it. So 1,553 times 100. And then we'll divide that by the number that's across from X. And we're going to round this to a whole percent since they didn't specify. So that's going to be 32%. So he's paying 32% of his monthly income on his rent. Now let's solve it using the equation method. We would have said the rent is what percent of, actually we'll just say X percent. We'll write it out. Of 4,850. Okay, so 1,553 is X times 4,850. We divide by the 4,850, and I will show this on my calculator that notice you're going to get a decimal answer here that you have to remember to convert to a percent. So 1,553 divided by 4,850. Notice that gives me X equals 0.320. Then it keeps going. And notice this is as a decimal when you're doing equation form. So we have to convert that by moving it two places to the right and adding our percent symbol. And I did round the same way. I rounded to the nearest whole. Okay, so that's it for the notes video. So it's not very long in terms of like the instructional part. What I want you to do though is after you've taken your notes on this, do your Kahoot, get that out of the way. Once you've completed it, it'll show me that you did it. And then that will give you the points that I would normally award for like a Monday class. Make sure you're working on homework and things like that, taking quizzes when they're due, keep up with your calendar, make sure you're looking at all of that. Another thing they had on the calendar for the course is for you to look at the project two information or project one, sorry, information before we come back on Wednesday. So I just want to show you where to find that. Let me pause my share real quick. And let me pull up our Ivy Learn. I just want to make sure you at least look at it. You don't have to start the project in any way. That's not the goal. That's just for you to kind of be aware that it's coming up. It'll be due right after the midterm. I think it's that Friday or Saturday right after we take our midterm exam. So you want to work on it sooner than later, obviously. But it does not have to be started between now and Wednesday. We just want you to kind of look at the material. So let me do my resume screen share. So now I'm in our course. And if you go to modules, I want you to look at module 2, and there's the information for project 1. So what I would like you to do sometime before Wednesday, if you can, this is the start here. This is all the information about what the project is. I would download this because honestly, that is easier. And maybe print it. It's easier to kind of look at it if it's something you have right in front of you. It's a long document, so I do want you to like glance through it and read through it. You don't have to like get into the nitty-gritty of what every single step is, but kind of look at what the requirements are. There's some examples of like how to write sentences when you're writing a statement, things like that. Like, you know, what's a good answer, what's a not a full answer. Like it's really kind of giving you almost like a little bit of a rubric. So read through that. And then I want you to skip, the next part is actually the template you'll need. Like I said, you don't have to start it right away, but that's the template we provide. And then I want you to watch the video. Okay. There's two videos about the questions that are involved. So make sure you watch those. Okay. And again, that's something just to do, even if you don't get it done by Wednesday, all of that, just make sure you're getting it done sometime in week 2. We will talk a little bit in class together about the project. That'll be, I think, Wednesday of next week. But you want to start looking at it yourself as well. And that's all I have for today. So have a wonderful, wonderful weekend.